Yes, we have completed the concepts of how to solve the differential equations as well as the special differential equations. So now we start the applications of first order and first degree differential equations. Among them, we have the first one as orthogonal trajectories, and the second one is Newton's law of cooling, and the third one is Newton's law of natural growth and decay, and fourth one is chemical reactions. Then let's start the first one, that is orthogonal trajectories. If the family of curves cuts each member of the given family at right angles, then that family of curves is called orthogonal trajectory of the given family. Or we also write it as two family of curves are said to be orthogonal trajectories to each other if every member of one family cuts each member of the other family at right angles. We find this particular phenomena in the engineering like electric fields, heat flow and fluid flow. In fluid flow, the streamlines will be always perpendicular to equipotential lines, or we also call it as the lines with constant velocity potential. We will see an example of orthogonal trajectories. If we see here, y is equal to mx gives a family of straight lines where m represents slope, and x square plus y square equal to a square gives the family of circles where a is the parameter. They both act as orthogonal trajectories to each other. By varying the slope m, we can have the family of straight lines like this, and by varying the radius a, we can have the family of circles like this. You can observe from this figure that the angle between them is 90 degrees. That's the reason we call these two as orthogonal trajectories of each other. Now we'll see how to calculate or how to find out the orthogonal trajectories of given curve in Cartesian form. So we'll write the procedure to find out orthogonal trajectory in Cartesian coordinate system. So for the first step, let f of x comma y comma c equal to 0 be the equation of the curve in Cartesian form. We have taken some equation of the curve in Cartesian form with c as the parameter. Now first we have to differentiate it with respect to x, and we have to eliminate the parameter or the arbitrary constant c from these two equations. Then we'll get a differential equation of the form g of x comma y dash equal to 0, or g of x comma y comma dy by dx equal to 0. Then we replace dy by dx with minus dx by dy, or y dash with minus 1 by y dash. Then we get a differential equation of the form g of x comma y comma minus 1 by y dash equal to 0, or g of x comma y comma minus dx by dy equal to 0. But the question is, why we are replacing dy by dx with minus dx by dy, or why we are replacing y dash with minus 1 by y dash? We have learned in the lower level that the two curves will be orthogonal or perpendicular to each other when the product of their slopes equal to minus 1. That is, m1 m2 is equal to minus 1. Then I can write m2 is equal to minus 1 by m1. That's the reason we are replacing dy by dx with minus 1 by dy by dx, or that becomes minus dx by dy. So I think you understood why we are replacing that dy by dx with minus dx by dy, or y dash with minus 1 by y dash. Then we get a differential equation like g of x comma y comma minus 1 by y dash equal to 0, or g of x comma y comma minus dx by dy equal to 0. Then by using the suitable techniques what we have learned till now, we have to solve this particular differential equation. Then the resulting equation will become orthogonal trajectory of the given family.